Now recording. All right, let's begin. So, exercise 2C, let's do a bit of recap for those who weren't here or at least copied the notes but forgotten what we did. So, let's recap. Exercise 2C is about triangles. The first part of the notes was to identify types of triangles. So looking at your notes, if you don't have it, you can fill it in now. There are three types of triangles that are the main ones. Name the three types of triangles that we have copied down in terms of our notes. Name me one type of triangle. Let's go, Leon. We have a scalene type of triangle. Name me another one. Can I please have... Yes, Elliot. Isosceles. Very good. Name me the last common one, which is... Yes, Elizabeth? Equilateral. What you need to know of the three are the properties. Name me a property that you know for a scalene type of triangle. Can I please have... Let's go with man. What's a scalene have? What's a property? Good. They have all different sides. So side lengths are all different. What else is there? There's another property, Halshuan. Scalene. How do we know if something is scalene? So all different sides, so I'll draw it. They all have different side lengths. So 1 dash, 2 dash, 3 dash. What else do they also have, Halshuan? So all different sides and different angles. Very good. In order to have different sides, each one has to be different. So clearly that's an obtuse, acute, and these two acutes are not the same. So how do we show it in our diagrams? You can use 2 curves, 3 curves, or you can use a different symbol for each corner to show that they all have different angles. Okay, the dashes also tells you the different sides. Let's do the same. Isosceles. An isosceles triangle has what property? Name me one. Can I please have Sully? What's the property that you know about an isosceles triangle? Good. 2 same sides. So they have 2 sides that are the same. So here's a triangle that looks like it. Here's a triangle where both 2 sides are labeled with a dash, meaning that the 2 sides are equal. But that means the third side's not equal. Okay, so third side's a different side. So I'm going to do 2 dashes there. But also, what else do we also know? They have another property for an isosceles triangle. Give me another property. Yes, Ali, again. 2 equal angles. Very good. Now, one of the ways to find an isosceles or which 2 angles are the same, find where you can cut it in half so that it's symmetrical. In the way I've drawn this one, it's symmetrical if I cut it vertically down. So that means whatever's on this side, this angle is equal to this angle. Okay, so whatever's there, if that's 30, then this side is 30 as well. So think about symmetry. Think about where you can cut it in half. So that's an isosceles triangle. Then you go to your third type of triangle. Your third type of triangle, you have currently an... Oh, what's going on? I can't seem to highlight it. Let's do it again. No, it's not working. Now it's working. Oh. So terrible. Let's try to give it some space. Equilateral. What is the property for an equilateral? Can I please have Wendy? Equilaterals. What do we know about equilaterals? All same sides. So they all have the same sides. So if I draw a triangle now, not just 2 sides, but all 3 are equal. That is an equilateral. Okay, make sure to copy this down, especially if you weren't here on Monday. And here we go. We've got a second property as well. If all sides are the same, then, Kyle? All angles are the same, which in this case would be 60 degrees. Very good. For an equilateral, we know it has to be 60 degrees. How do we know it's 60? Because all angles are the same. But one property of all triangles, if you add all the angles in a triangle, yes, very good. It must add up to 180 degrees. Since you've got 3 corners the same, 180 divided by 3, that's why we know equilaterals has to have 60. 180 divided by 3 is 60. Okay? And then I gave you one last rule, which I haven't shown you the proof for it at all. If you have a triangle, which we know the interior angles add up to 360, but if I extend that length, if I just made the line and just made it a bit longer, that creates an obtuse angle. So let's call that C. There's a rule that if you add the two opposite angles, so this is the opposite angle, so those are the two interior, it's inside, and opposite to C, let's call this A and B. If you add these two, A plus B will equal to the exterior. What's the name for this theorem? What's the name again? Leon. It's the? No, that's a different one. Oh, that's because I wrote A and B, C. I see what you're thinking. That's very close. Pythagorean theorem is A squared plus B squared equals C squared. What's this rule? It's in your notes. Sully. It is not co-interior. It's called the X. Very good. This is called the exterior angle theorem. Exterior angle theorem, the reason why it's exterior is because it's the outside angle. These are called the interior angles inside a triangle. So C is the exterior angle. You can find the angle of the outside. If you have this triangle, you can find the two interiors, add them together, and they'll equal the outside. There's a proof for it. For those who are strong with their algebra or logic, you can prove this. Otherwise, memorize that. Okay?
Because if there's the other angle inside the triangle is D. D plus C is 180.
Why?
Because the straight line is 180.
Good. So let's slow down a bit. So Will's on this point. So if you notice that little missing angle, let's call it D. D plus C will give you a straight line. That's a supplementary angle. So it should add up to 180. Very good. And we also know, and this is how you can see the proof, A plus B plus D. So they add all the interior angles. We know that in a triangle, it should also equal to 180. But what's interesting here is that if they're both meant to equal to 180, then that means D plus C is equal to A plus B plus D. Now, can anyone see where the rule is coming from? Since they're both adding D's, one C plus D, and this one is A plus B plus D, they both add a D. So that means C must be the same value as A and B. That's why we got the rule as A plus B must equal to C. Okay, so, or if you know some algebra, you can say minus D on the left, minus D on the right. That cancels out and you get C equals A plus B. That's only if you know a bit of algebra, but if you don't, there's a bit of logic that whatever D is, these two must be equal. So hence C equals A plus B. So that's the proof for the exterior angle theorem. But if you didn't understand that, that's okay. You just need to know when to use the rule. Let's do some examples now. So that's a recap of what we did on Friday last week. Or it was Monday. I think it was Friday last week. So let's go back to your notes. Let's go back to the first page. Example 1. Let's fill this in. Example 1. I've got a triangle. It has no notations, but clearly looking at this triangle, what type of triangle do I have? Let's go with bow. What type of triangle do I have in part A? There's only 3 types. Scalene, isosceles, or equilateral. Which one is it? It's a scalene because all sides clearly look very different. Scalene. Other than that, I have nothing else. All I have is 23 degrees plus 110 degrees plus 80 degrees. We know that all the angles in a triangle must add up to what, Ashwin? Did you put up your hand? No, I'll just call you out anyway. If you add all the angles in a triangle, they all must add up to what? 180. Very good. So now, if you think about it, 23 plus 110 plus 8 must equal to 180. Well, let's work this out. 23 plus 110 gives you what? Can I please have Elliot?
It would be 133.
133, good. So 133 plus something has to equal to 180. Let's do a bit of quick maths.
180 minus 133.
Very good. That's another way to do it. So you can do it either counting with your fingers or you can do it the other way. Do 180. Instead of adding, you can do the reverse, minus 133. And that should give you what? Can I please have Wilbur? What's 180 minus 133? 47 is correct. Very good. So that's one of the questions that you're going to get. If you get a triangle, we know that they all have to add up to 180. You just make sure they add up to 180. Okay, so some of the questions will be that easy. Next one, you have to use a property. Question B. What type of triangle do I have for B? Can I please have Colleen? What type of triangle is this? It's an isosceles. Very good. And we know that because they both have two dashes. The two dashes imply that they must be equal in length. But if they're equal in length, you can see there's a symmetry here. I can cut this triangle in half and it should look symmetrical because what's on the left must equal to what's on the right. So let's zoom in. If this is angle A, this must be angle A as well. So together, again, we know that if I add 48 degrees plus A degrees plus A degrees, let's write that down. So 48 plus A must equal to 180 because you're adding all the angles in a triangle. Now this part might look a bit confusing and you might be like, I don't know algebra, but it's okay. A plus A just means you're doubling it because you got two of them. So you're really saying 48 plus double of something is equal to 180. Now let's just think about it for a moment. 48 plus what will give you 180? Yeah. If you think about it, 48 plus what will give you 180? You can go 180, take away 48. And that tells me this has to be 132. So even though I don't know what double of this number is, I can work backwards. I can say 48 plus something has to give 180. So that means double of something has to equal 132. So double of what will give you 132? 60? 66. If you didn't know that, you can do the reverse. Instead of timesing it by 2, you can say divide by 2. You can halve it. Because you know there's 2 of something to make 132. If you halve it, well, then you get 1 of each. So halving 132 is equal to 66. Okay, again, at this point, you can use a calculator if you're not strong with your divisions and times. Use a calculator, adding, subtract. You use a calculator to make sure you're getting the correct answers. Okay, because it's about your layout, get your layout right, and then the rest, it's okay with using a calculator for now. Okay? All right, let's go to the next page. Flip over the page. Let's look at other problems. This one. I just taught you the theorem for this one. Who wants to have a go? Hands up. Leon. How do we do this one?
We have to find B, right?
We have to find A.
So A plus C has to equal to 164 degrees.
Very good. Exterior angle theorem. Remember, the angle on the outside of the triangle is equal to the opposite angles inside the triangle added together. Now, this little box here, what's the angle for the little box? 90. Very good. That means right angled, so it means it's 90 degrees. So what they're really saying is this angle A plus 90 has to equal to the exterior angle, which is 161. So now you can do again, do a bit of trial and error with your fingers, or you can reverse it, 161 take away 90, or what adds up to 90 to give you 161? 71. Is that right? Yes, that is correct. So A must equal to 71. Again, you can use a calculator. You could have done 161 minus 90, and you would have got 71 as well. Okay? Last example looks tricky, but actually isn't. First thing, identify the type of triangle you have. What type of triangle do I have for D? Can I please have... Yes, Ashwin. Oh, it could be scaling if you're looking inside. I'm looking for the outside. What's the outside? There's a big hint for the big one. Not equilateral because there's only 2 dashes. Isosceles because it only has 2 dashes. So remember, you see 2 dashes, these 2 sides are the same. There's only one type of triangle that has 2 sides the same. It's an isosceles. So if that's true, listening, you can cut it in half. Find where you can cut this shape in half. Clearly, this line already cuts it in half. So that means whatever is on the top, if that's 72, that must be 72 down here as well. Because this angle here, this side is equal to that side. So that means this angle is also equal to this angle up here. They're both symmetrical. So that's A, that's A, that's the blue line, that's the blue line. Then that's 72, that's 72. So let's put it together. 72 plus 72 plus A plus A. So all those three corners should add up to 180 degrees. So you should have A plus 72 plus 72. Now let's work it out. A plus A is just double of A. What's 72 plus 72 equal to? 72 plus 72, let's go with Tom. 144. So just like the previous example, something plus 144 gives you 180. What's that something? What's that number? Something plus 144 has to equal 180. What must that number be? Leon.
It's 2 times 8.
Yep.
2 times 8 plus 144.
Yes, but I'm saying, so this is 144. 144 plus what to give you 180?
Oh yeah. You have to minus 180 by 144 and then.
Which is what?
and half.
What's 180 divided by, plus, take away 144.
144, that's.
Something plus 144 to give you 180. 36, very good. 36 plus 144 gives you 180, but like Leon said, double of something has to equal to 36, so double of what will give you 36? 18, very good. So A must be 18. Again, if you didn't know that, you could have done 36 divided by 2 on your calculator, because you're halving them, and you can get 18. Yeah.
Can't you just do, since you know there's the triangle?
Oh, that's even smarter. That's true.
Could you just figure out what A was with that?
Yes, you're right.
Did you really?
I didn't see that actually. Did you see what Elizabeth is saying? This is a right angled triangle and it's still a triangle. So it actually was easier to do it this way. That was 90 degrees. This is 72 and this is A. So that means A plus 90 plus 72 has to equal to 180 and you would have got A straight away without doing what I just did. That's true.
I mean, the other way first way you got it correct, but it's just slower.
It's longer. That's right. So both is correct, but it's good that you can see both. You can see both ways. Very good. Excellent. That's exercise 2C. Remember, I don't expect 2C to be due. Elliot? It's big biceps. Please don't eat his arm. What's due is 2B. So if you haven't started 2B, can you please start on 2B or finish off 2B? It's due by the end of this week. I want to see that. You would have had 2 weeks to do it. If you use this session and tomorrow's session, you have 80 minutes to complete it.